go over my individual sprint review. And so this is for the previous sprint, sprint 1. And first I want to talk about just about what I'm going to be going through. So first I'm going to go through the feature breakdown of what I did. I'm going to talk about some of the minutes that I worked on it, just about the time, how many days it took me to get going. I want to show you a demo of it working, and then I'm going to go through the GitHub and show you the commits that I've done, and also the GitHub, and also just walk through some of the code. So first, I worked on the CNN. This sprint, I spent time working on the model to read user information and then use that data to guess whether they are stressed, which it would be a 1, or not, which would be 0. And so this was pretty straightforward. I used pre-made libraries from Python that made it super easy. I used a data set that was randomly generated based off real values, but basically just if it went over in a range of stressed in a few areas, we considered it stress. So if your heartbeat was up, but your temperature light was all down, then we kept it as calm. But say your heart rate was up, your temperature was up, and let's just say your O2 was a little bit lower, we would say you're stressed. And so that was just data that we created. And I want to say I spent like maybe 2 days working on it. I spent 1.5 days working on the actual model, getting it to work the way we wanted to, generating data, and then maybe another day working on getting it to load. That was just a little tricky because I didn't know how to do that quite, so I had to figure that out. But other than that, yeah, it's maybe a few, like 3 hours, 4 hours to get everything kind of working, and then maybe another 2 to 3 getting everything working the way I wanted it to. And so I'm gonna show you a demo really quick. This is currently the model being trained and it giving us some information. And then what I will do is go on to load model. Or here's that CSV that we created. And this, oh, it's right here. But I don't want to show any code yet, so I'm not going to do that. But yeah, so this is going to train the model. This is going to give us, based off that CSV that I showed you, a prediction, and then the accuracy. So our accuracy right now is 89.38%, which is pretty good. We don't want it to be too high because then we're going to be overfitting, and we don't want it to be 50% because that's just guessing. So I feel like 89 is a good spot, and you can do this as many times as you want. It'll get different results based on the way it learns, goes to the data. And so if you want to load the model, which I'll show you, but this has data preloaded onto it to test it. And so you'll load, you'll run it, and what it'll do is it says, okay, you're stressed. And yeah, so based off the data, this person was stressed. And so that's what it does. And that's all through Python. We want to put that up into the cloud, into Google Store, so that whenever someone gets new data or something is off on their data that it comes in, we get to send it to that function, and it will tell us whether or not they are stressed or if they're calm. So here I'm going to go through the GitHub, and I'll pull that over right here. And so this GitHub, this was the initial commit that I've made, and this was by me up here. And so you'll see that I imported NumPy, which was needed. And this was for add noise. So I created a file called add noise to basically create some variation within the data that we already generated. So each time it's going to create different variation, it's going to create different noise levels, it's going to create different outliers to be able to like mimic a little bit closer to real world what actually happens in the real world. Everyone is different. We might get someone who is closer to the outlier, so they're closer to the edges, or they just have really noisy data, and so we want to be able to handle that. So this function add noise basically takes a random number from the features, and what it'll do is it'll take those features and add some noise to it. So if the heart rate is 10, it'll take a random percentage between 10%, and so if their heart rate's 100 and it does 10, then it'll add 10% of that. So in this case, that would be 110. So their heart rate goes from 100 to 110. And that's to be able to get some out of bounds, maybe some different data. Add noise labels. And so this was to change some of the labels, so calm or stressed, to actually be flipped. So if it's stressed, it's going to get switched to calm, and if it's calm, it's going to get flipped to stress. And so this is to just add some noise to those final labels. So get some more variability in there. Maybe some data gets put in wrong, and so we want to be able to handle that and not be the model be surprised when it sees that. Outliers. This is just the range of outliers, so it'll take the biggest one out of all of it, and then out of all the data, and then it'll add a certain percentage to it. So this one's 10% or 50%. So it'll take a feature and just add 50% of that. So it'll just increase it by half to get those outliers, to make sure that we are handling some odd cases if needed. The next one is load model. So this is what we use to load the model that we created. So each time we run a model, it gets stored in this stressed calm model.h5. And so this just right here, what this does is it loads it to loaded model. Here we created a NumPy array for new data. So this is to simulate heart rate, lumens, I think, and then some other data that we have, which is on the data CSV. And then you get a prediction, and you load the model, and you predict with the new data. And that's how we got that prediction of 1 for stressed. So this person was stressed based off their data. And so here's the machine learning that I use. So I use TensorFlow. I use their sequential model, which also is their random forest classifier. So I believe it's not a CNN. But I think this one, from my research, works better with the data that we're trying to use. But with enough data, all of them can work pretty well. So this is the file path that we're going to use to get that data. So if anyone wants to pull this, they just basically have the file. They just need to update that file path to be able to go to stress calm data.csv. You use pandas to read the file. You take the features, which is the sound, so heart rate, light, temperature, humidity, sound. You take the labels, and you get all the values from those labels. So you just get everything from the CSV file. Here we add the noise, which I just explained above. We add outliers and noisy features, and then noisy labels. And once we do that, we encode everything. We fit it, and then this. So right here, it says use to convert the labels into numerical values. So 1 is stressed, 0 is calm, and this is where we do it, right here with this encoder. Then here we split the data to have our train and test data. And so we have our X train, X test, Y train, Y test. And that'll just split it to, I think it's about, 20% of our data is test data, and then 80% is train data. So the more data we're going to have, the more accurate it'll be. But for now, I think we have about 4,000 sample data, so there's a good chunk. The model is a random forest classifier, and it's going to have 100 estimators, and then the random state isn't that important. We're going to we're basically going to train it right here with the X train and Y train, and then we're going to predict using the X test to get a Y prediction, and then we compare that. So we compare the accuracy of the actual Y test to the Y prediction, and then we print out that accuracy right here. And then this is a pre-made function that just gives us some more data based off the how well the model did, and then this just saves that model to our file so that we can pull it up later. Okay. Sorry. I think that's everything. Yeah, I believe that's everything that was needed for this. Yes, sorry, that was everything that was needed. Thank you, Dr. Sanders, and I appreciate the time you took to listen to this.